We are going to be talking about the classification of matter today. So first of all, what is matter? Matter is anything that has mass and takes up space. So if you think about it, you're made up of matter, the computer you're watching this on is made up of matter, pretty much anything in your known world is made up of matter. The only thing that necessarily wouldn't be made up of matter is something that's made up of energy. So matter can exist in four basic states: solid, liquid, gas, and plasma. The most common three are solids, liquids, and gases, although I'm going to talk a little bit about plasma. Or you can have a mixture of any of those substances combined together, and we'll talk a little bit more about mixtures later. So the first state of matter is solid. So solid molecules are basically locked into place and they have a fixed shape, fixed volume. They take up a certain amount of space in the room. So I'm looking at my desk right now, and my desk is in a very specific location. It's in a fixed volume, and that is not going to change. I also cannot compress the desk, meaning that I can't turn it into a smaller version of the desk. So those molecules inside the solid are completely packed together, held tightly together. But the thing is that even if it's a solid, those molecules are still vibrating in place. It's just very slight vibrations that you can't perceive with your eye because molecules are so tiny. The next state of matter is liquid. So liquid, the particles have a little bit more ease of access to move around. They're still really, really close together. If you think of a glass of water, those water molecules are just going to sit in the glass. They're attracted to each other, so there's forces keeping them together. But they're still able to move around. So they have variable shape. If I take a glass of water and I pour it into a different shape glass, it's going to take on the shape of whatever the glass it's in. It has a fixed volume, so if I have 10 milliliters of water, I've got 10 milliliters of water. That's not going to change. And it's also virtually incompressible. There are situations where you can compress liquids, but if you think about it, if you stick your hand in water, you're not going to compress the water. Your hand's just going to go straight through the water. Third state of matter are gases. So these particles tend to be more separate. They tend to take up more space. They take on variable shapes and variable volumes because the particles are moving around a lot more. They're also very easily compressible. So you can see the very distinct differences between the three pictures. In a solid, you have all of the molecules locked together in a structure. The liquids are kind of free-flowing, but they're still very close to each other. And the gas molecules have the ability to move around in a container. And you notice that the gas molecule container has a lid on it because those gas molecules would fly out if the lid wasn't there. There's also a very specific distinction. It's called vapor. You use the term vapor when you're talking about another state of matter that's in the gaseous form. So if I have a liquid and it turns into a gas, I would call that like water vapor. You can also use that term for solids. So whenever you have a gaseous state of something that is supposed to be or was in a different state of matter, you would use the term vapor. So a little bit about plasma. Plasma is really cool. On Earth, plasma is most commonly found in fire, lightning, and auroras, which happen at the poles, North Pole, South Pole. So plasma is the fourth state of matter, and it is the most common state of matter in the entire universe. Makes up 99% of all matter in the universe. So all stars, quasars, X-rays, supernovas, pulsars, all of that is made up of plasma. And plasma is kind of a complex idea, but simplistically, it's just ionized gas. So what happens in an atom is you have protons, neutrons, electrons. Those are the three basic subatomic particles in an atom. And whenever you have plasma, they basically separate, and the electrons have the ability to, in simplistic terms, they have the ability to kind of just free flow, and they take on another shape, and so they morph into this structure or unit that acts together versus as individual electrons. So ionized gas is just a charged electron, and they kind of behave as a unit rather than individually. It's pretty cool. All right, so let's talk about a flow chart of matter. So matter can be broken down into different categories, and I put together this flow chart to show you that. So first of all, we need to be able to figure out Matter is anything that has mass and takes up space. Can it be physically separated? So if it can, then we consider it to be a mixture. If it can't, well, we consider it to be a pure substance. So I'll go through this individually. So let's go back to the mixture. So if I can separate matter, it's considered a mixture, and there's two very distinct types of mixtures. There's homogeneous mixtures, which are called solutions, and then there's heterogeneous mixtures. The difference between those is the uniform composition. So just a quick example would be if you have like an Italian salad dressing where you have oil and vinegar and you have spices, you can clearly see those spices in the mixture. That would be an example of a heterogeneous mixture because you can see the different parts of it, versus a homogeneous mixture would be, say, like a glass of lemonade. All you know, it's kind of a yellow substance, it just looks like a glass of lemonade. That would be considered a solution because you really can't see any distinct parts to it. The opposite end of the spectrum, if you cannot physically separate matter, you consider it a pure substance, and there's two types of pure substances based on whether or not they can chemically decompose. If it cannot chemically decompose, meaning it can't break down into smaller parts, it's considered an element, which is based on the element of on the periodic table, elements off of the periodic table. And then if it can chemically decompose, meaning it can break down into smaller parts, we consider it a compound. So getting more into the pure substances, we're going to break it down and talk about what it means to be a compound versus an element. So elements cannot be chemically decomposed. So there's elements on the periodic table, and they all have very unique properties. A couple of examples, copper, wire, and aluminum. You can't break copper down any further, otherwise it's no longer copper. Same with aluminum. So I have copper, aluminum, chlorine, and then there's sodium metal. Pure substance on a compound, on the other hand, which can be chemically decomposed, is made up of more than one pure element. So as an example, you can take sodium metal, add it to chlorine gas, and turn it into table salt, which is called sodium chloride. So you can take those two elements, combine them together to make a compound, and you can also take a compound and you can break it back down into its individual elements.
Sodium metal is heated until it melts and just begins to burn. Then it is immersed into the yellow-green chlorine gas. The sodium begins to burn in chlorine with an intense yellow flame. It produces a white smoke of sodium chloride. We are observing the exothermic reaction of sodium metal with chlorine gas, producing the white solid sodium chloride. Afterwards, the glass spoon contains only white solid sodium chloride.
So again, that's just an example of how you would take two elements and turn them into a compound. And you can also do a reverse reaction, which is just chemical decomposition. Alright, so then the opposite side of that chart were the mixtures. So can it be physically separated? If yes, it's considered a mixture. So mixture is the combination of two or more substances that can be separated. So you have a homogeneous mixture, which is also called a solution. And a homogeneous mixture just looks the same throughout. You have really small particles, you can't see anything. An example of that would be apple juice, basically anything that you would drink that just looks pure. So apple juice is really made up of water and apples, but it all looks the same, so it's homogeneous or the same. The opposite of that would be heterogeneous, and that means that it looks different. Hetero means opposites or difference. So generally you have two substances mixed together like oil and water. You can clearly see the oil in this picture mixing into the water, but they're not mixing together, they're staying separate. There's also, I would consider this to be a feldspathic granite, so that pink color is from a feldspar mineral. And you can clearly see the different specks in the rock, which is heterogeneous. It all looks different.